Hello, this is AP Chemistry Topic 5.7, Introduction to Reaction Mechanisms. The objective for today is to identify the components of a reaction mechanism, and also you're going to have to be able to obtain overall reactions, recognizing catalysts and intermediates. Many reactions do not occur in a single step. In fact, they take multiple steps, most likely. This is related to collision model that we've talked about before. In reactions that do involve multiple steps, there are a series of elementary reactions or steps that occur in a sequence. Each of those is called an elementary reaction, and then from there you can combine and give the overall reaction. Also, you can get the rate law for elementary reactions, all that type of stuff. So as an example, ozone or O3 converting into oxygen occurs in technically 2 steps. The overall reaction, however, is just two molecules of O3 gas producing 3 molecules of O2. But in reality, there's a series of steps that make those different molecules. And you can see that you're canceling out the single oxygen on both sides. And in doing so, that's actually an intermediate. An intermediate is a molecule or atom that is produced and then used up in another step and therefore no longer present in the overall reaction. When you're combining elementary steps, you must match the overall balanced equation in order for it to be valid. Like I said, O is an intermediate. It appears as a product of the first step and is then consumed. Here, we're talking about now catalysts. A catalyst appears as a reactant in the rate determining step, but will then appear as a product of a later step. Catalyst will not appear as a reactant or product in the overall reaction. So they're going to show up in maybe in your elementary steps, but they won't appear because they'll be canceled out in when you get the overall mechanism. So catalysts, what they do is they speed up reactions. They will appear as a reactant, but then disappear later on. So we're going to see some of this in a bit. Write the overall reaction represented by the mechanism below. By combining steps and eliminating catalysts and intermediates. You have to identify if there's a catalyst or if there's an intermediate. So you have to obtain the overall reaction. So we can see that we're doing this. Remember, we're just adding on either side of the arrow, but we're also canceling stuff out if we need to. So for example, we're looking. On my step 1, I have N2O. On my reactant side, I'm producing N2 plus O. In my step 2, I still have N2O, but I'm using the single O here. That's from here in my second step. You notice that's only 2 steps, so that means that O is going to be canceled out. It's produced and used up. That means that is going to be an intermediate. As you can see, when I'm adding these, so technically I have N2O on my left side of the arrow for my first step and it's still on the left side for my second step. So I need to add those together. On the right side of my arrow, I have N2 and N2, so that's 2 N2s plus O2 gas. Identify the catalyst as a species, blah, blah, blah. So it kind of gives you the definition of what it is, but you may not see that definition. So you have to know that a catalyst is present as a reactant in the first step and a product of the second step, and we don't have that. Identify the intermediate as a species that is produced during the first step and consumed. So that's going to be our O. gives you a mechanism. Which of the following mechanisms is the valid one for the reaction shown, and you have to explain your answer. So we have two possible mechanisms. We had to figure out which one is the correct one or the valid one. So our first step is to cancel terms on both sides and then gather like terms. Sounds like a math class. Okay, so let's look at step one. Mechanism one. So we have to make sure that we end up with this in the end. So let's look at mechanism one. So I have N2O2 being produced from 2NO, so that's good. I do have that. I have a 2NO on the left side. So that's going to be used up. So cancel. Do I have any other like terms? I have my O's are my like terms on either side. Do I have any other like terms that are on either side, on opposite sides? No. So now I can combine. So I have 2NO and an NO on the same side of the arrow. So my overall mechanism would be 3NO. That's all I have. Arrow now, 2NO2. So it looks like that doesn't even match with our thing. So it can't be that one. Let's double check the other one. So I have NO plus O2. Good. I have that here in my overall mechanism. NO3s are canceling out on both sides. I have no other terms. No other terms on on opposite sides. I'm just going to gather my like terms if I have any. So it looks like I have 2NO gas plus O2 gas producing 2NO2 gas. So it looks like mechanism 2 is my most valid mechanism. However, we need to explain it. So this is where I'm afraid we all may mess up in your explanations on the AP exam. So let's see if we can figure out the best way to word this to explain what it is that we want to say. So let me create some space on top. Good luck to me writing this. The second mechanism is valid. That's what it's asking. So you need to say it. You need to address what it is that they're trying. Like if you just solve it, that's not explaining it. So the second mechanism is valid because the overall reaction matches the stoichiometry of the reaction provided. Kind of the best way to explain what it is we're trying to say. So, all right, gentlemen, if you have any questions, please let me know. Hit that like and subscribe, blah, blah, blah. All right, thanks, bye.